Okay, so today's video is on sine and cosine using 45, 45, 90 triangles. So let's review what one of those triangles looks like. So if I have a triangle, I know one angle is 45, the other two are 45 degrees, and then I know that I have my two legs that are the same measurement, and then I know I multiply by root 2 to figure out what the hypotenuse is. So the same thing could be true if I tell you that one of the side lengths is 1. How would you figure out what the hypotenuse is? Well, you would multiply 1 by root 2 and you would just get root 2. Okay, so to find the sine of 45 degrees, so these both have degree symbols, we go ahead and we're going to graph on our coordinate plane where 45 degrees is. So when I do that, I know 45 degrees is in the first quadrant and it looks something like this. So I know that my angle in here is 45 degrees. So now to find out the sine of this angle, what I'm going to do is I'm going to drop down and make a triangle. Do we see this triangle right here? What happens when I drop it down and I make a 90-degree angle right there? Now I know that it's a 45, 45, 90 triangle, and just like in the first slide, what we did is we know that these are both the same, so let's call them 1. Then I can figure out the hypotenuse being root 2. So to find the sine, this is where we have to keep in mind our sine, cosine, and tangent. So we think about SOHCAHTOA. All right. And when we have sine, we're dealing with opposite divided by hypotenuse. So I'm here sitting at 45 degrees right here. And I go across for my opposite and I grab the 1. And then I divide by my hypotenuse, which is root 2. And we can't leave it like that, so we rationalize. We multiply by root 2 over root 2. And I see that my final answer is root 2 over 2. So the sine of 45 degrees is root 2 over 2. Now, take a moment and see if you can figure out how to find the cosine of 45 using the same method that we just did. Okay, so hopefully you figured out that it's the exact same thing. So if I have 45 degrees here, I can drop it down, 90 degrees, 1, 1, root 2. And my cosine would use my horizontal and my hypotenuse. So we would get that cosine of 45 degrees would be equal to 1 over square root 2, and we can't have that. So the cosine of 45 degrees is root 2 over 2. Okay, so now let's look at radians. So if I look at the sine of pi over 4, now at this point we should kind of figure out that pi over 4 is a fourth of a whole pi. And we know that a fourth is half of a half. Okay, so when we graph this, we know that pi over 4 is exactly in the middle of quadrant 1. So here's pi over 4. And one thing we should probably start to recognize is when we're dividing by 4, that it's going to be a 45 of some kind. So I know that my reference angle is 45 degrees. And so I'm going to write it in degrees here just so that we can all see it. So when I drop this down and I go across, 1, 1, root 2, and again we have that 90-degree angle at the bottom, we get that it's going to be 1 over root 2. Or root 2 over 2 being our sine of pi over 4. All right. Things look a little bit different when we start moving out of quadrant 1. So if we're looking at the sine of negative 5 pi over 4, think about how you would do that. So take a minute, see where you would graph it, and then we'll come back together. Okay, so now if we draw this, we know that negative 5 pi over 4 happens when we go backwards. We end up in quadrant 2. So instead of putting an arrow on the end, we're just going to leave it like that. And then we know that we can drop it down. And we know a couple things. We know that this is a 45-degree angle in here. So my two lengths of the sides have to be equal, but keep in mind that we're dealing with a coordinate plane. So when I move up in the positive direction above the x-axis, then that's going to be a positive number, so that's going to be a positive 1. And if I were to move down below the x-axis, that would be negative. Just like if we move over to the left side of the coordinate plane, we're moving to the left side of the y-axis, so it's going to be a -1. And then our hypotenuse is always positive, so it's always going to be a positive number. The only ones that have signs that change are the components that we drop down and draw across. So when we figure out what the sign of this is, we do it exactly the same way. We think about SOHCAHTOA. So opposite, remember your angle is in here near the origin. So opposite over hypotenuse is a +1 over square root of 2. So that has to be changed. So sine of -5 pi over 4 would be equal to +√2 over 2. Take a second and see if you can come up with the cosine of that same angle, -5 pi over 4. Okay, so to find the cosine, we're using the adjacent, so this bottom piece, and then the hypotenuse. So it's important to recognize that the adjacent piece is negative, and then we're dividing by radical 2. So the only difference here is that the cosine of -5 pi over 4 is going to be -√2 over 2. So notice how those two are different. All right, so take a minute and do these next two. Cosine of 7 pi over 4 and the cosine of 3 pi over 4, and see what you come up with. Okay, so you should see for the first one that 7 pi over 4 is in the 4th quadrant. So when you draw in your triangle, you have a +1 on the x-axis and a -1 going down, and then your hypotenuse is radical 2. So the cosine of that is +√2 over 2. When we switch over to 3 pi over 4, you should have recognized that these two, the 3 pi over 4 and -5 pi over 4, are exactly the same thing, right? They're coterminal angles. So when we use 3 pi over 4, we're in the 2nd quadrant because we're going in this direction. And then we have a -1 in the denominator, or on the x-axis, and then a 1 on the y. So we get -1 over √2, so we end up getting a -√2 over 2. Okay, so now take a minute and do these last two. Sine of 225 degrees, and then the cosine of -3 pi over 4. Take a minute, graph them, and figure out what the sine and cosine of them are respectively. Okay, so one thing that you should notice is that both of them are in the 3rd quadrant. 225 degrees is when we start at 0, go 180, and then 45 more. And so this right here is where we graphed 225. Now we notice as we go left, it's -1. As we go down, it's -1, and our hypotenuse is radical 2. So when we do the sine, we do opposite over hypotenuse, -1 over √2, giving us, when rationalized, -√2 over 2. If you noticed, both 225 and -3 pi over 4 are exactly in the same place, so they are coterminal. One's written in degrees, one written in radians. So everything's exactly the same, but when we find out what the cosine is, we have to use the adjacent over the hypotenuse. So we get the same exact answer, but we're using two different pieces. So that's something to keep in mind. Okay, so you might have noticed that there are certain parts of our coordinate plane where things are positive and others are negative, and some of which are the same. So when we think about this, we have our quadrant 1, we have quadrant 2, we have quadrant 3, and we have quadrant 4. And a good thing to keep in mind is something called, well, it's an acronym. All students take calculus. And we write it in this way. And so when we go in this way, this tells us that sine, cosine, and tangent, which we haven't talked about, are all positive. When we get over to quadrant 2, only sine is positive, which means that when you do cosine and tangent, again, we haven't talked about tangent, these are negative. In the 3rd quadrant, sine and cosine are negative, but tangent is positive. And then quadrant 4, we have that cosine is positive, but sine and tangent are negative. So if we think about that, that'll kind of help us double check that we have our signs correct when we go around.